Welcome friends. Sorry for my voice. It's a bit choked because I'm suffering through cough and cold. Let us see a new project in which we are going to interface our first sensor, which is an ultrasonic sensor with Arduino, and the output can be seen on the serial monitor. Now, before starting with the project, let us understand what is an ultrasonic sensor. So ultrasonic sensors looks like this. It has four terminals. So VCC, then trigger TRIG, then echo ECHO, and ground GND. Now the principle of working of ultrasonic sensor is such that it is going to release some ultrasonic waves. The ultrasonic waves are similar to like our sound waves. We can hear the sound waves because they are placed in certain frequency. Ultrasonic waves are those waves which are not in that ear audible frequency, but they are type of sound waves. So what does the sensor do? It starts counting itself the moment it releases a ultrasonic wave. So there are two sensors or two what you call components, a trigger and a receiver, where you can see there is T written and an R written. So trigger and receiver, or actually trigger and echo. So what is going to happen is it is going to trigger or it is going to release a wave which is an ultrasonic wave, and that wave is going to travel through the medium and it is going to get reflected back from a surface, and that reflected ray will be received by the receiver. Now in that time period it will calculate when it has released the wave and when the wave has reflected back and received on the receiver. Means you can play with those signals of transmitting and receiving and get the desired output. So that is the basic working principle. So as I told you, there are four pins in this. So VCC. Now as we are going to deal with sensors, so always remember VCC is going to be your voltage input. So that would be connected to 5 volts because we need to run the sensors. So our VCC would be connected to 5 volts and ground will be connected to ground. So these are the two pins which are going to power the sensor. So as you can see here, I have connected the two pins. So 5 volts and ground, this entire rail. So as you can see, my VCC is connected to 5 volts and my ground is connected to negative. Okay. Now my two central pins, trigger and echo, transmitter and receiver, are going to be connected to digital pins. So I am going to connect it to digital pins 2 and 3. As you can see from the diagram, trigger is on 2 and echo is on 3. So this is my connection. It's a simple connection. Now let us see the code. Okay, so you can see the code. The code is quite simple in this. Now see, I have declared two variables, trigger pin and echo pin. So I have placed trigger pin and connected to digital pin 2, and similarly I have placed echo pin and connected to digital pin number 3. So as you can see here, it's on 2 and 3. Then in void setup number 1, I have used serial begin, which is going to begin the serial monitor at a baud length of 9600. Next I am going to use pin mode, which will set the pins, that is trigger and echo pins. So trigger pin is going to be my output, whereas echo pin is going to be my input. Okay. Now let us move to void loop. In void loop, I'm going to use the function digital write. So digital write, I'm going to read the trigger pin, okay, and digital write trigger pin and low. Then a delay of my 2 seconds, microseconds. Then again a digital write trigger pin high, and then a delay of 10 microseconds. Now here for microseconds, I have written delay microseconds. You can simply write delay, so that will be in microseconds also. Next, digital write trigger pin low. So what I have done, I have switched off the trigger pin. I have waited for 2 seconds. Then I have switched it on, means I have triggered it for 10 seconds, and again I have switched it off. Okay. Now reading the echo pin. So a new variable duration. So a long variable duration equals to pulse in. So pulse in is a new function. I am going to read the pulse of the echo pin. So pulse in, I am going to read from echo pin high. So if I am going to whatever echo pin is going to read, that is going to be saved in duration. Similarly, calculating the distance. So for that calculating the distance, I am using integer distance in centimeters. So distance underscore centimeters, which is equal to duration multiplied by 0.034 by 2. Now actually 0.034, it is the speed of sound basically. Zero is and it is mentioned in per second. So consider that whenever we are going to release a sound or release an ultrasonic wave, it is going to go, it is going to travel forward, get reflected and travel back. So whatever time is going to be, or whatever distance is going to be, it will be twice of that. So I am calculating the distance at in one direction. So that's the reason I am dividing it by 2. I hope this calculation is clear. So with the speed of sound, something is traveling to and fro. So that would be saved in our distance. Now last, I am using function serial print distance. So whatever is saved in distance will be shown here. So serial print distance in centimeters and in new line centimeters, and then a delay of 1000. So it's a simple program. I will leave the code in the description for you to refer. Okay. Connections I have already explained. Now I will be showing you the simulation. Okay. I have started the simulation. As you can see, there is an object, there is a range through which the ultrasonic sensor can work. Now what I am going to do, I am going to put my serial monitor on. You can see my serial monitor here. I am going to put an object at a certain distance. Now you can observe the distance, it is 211. If I move the object, it changes the distance, 298. Let's see, if I bring it closer, 55. So it has gone out from the range. Let's see, 29. So if I am going to be in the range, it can detect me and even track my movement. But the limitation is it has a particular range to it. Ultrasonic sensor generally can work in a particular range from anywhere between 5 to 40 centimeters. It depends upon the sensitivity of the sensor. So if you buy a costly sensor, it will be working for larger length. Okay. So I hope today's project was exciting. You can actually connect this physically and check out your output in the serial monitor. Okay, so thank you, have a great day, thanks for your time, kindly like, share and subscribe. Have a great day.